Welcome to Kindergarten Video on Demand. This video is an overview of Unit 2, Shapes in My World. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 2. In this portion of the video, we will review the AKS and Indicators of Achievement, or IOAs, for Unit 2. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. This unit has 4 AKS. Under the AKS, you will find the Indicators of Achievements, or IOAs. You will also see that we provided you with the state coding at the end of the IOAs, so that if you want to look up the resources on the Georgia DOE website, you're able to find the state IOA that is related to the GCPS IOA. AKS 2 is an ongoing AKS in which students use the count sequence to count forward and backward in sequence. IOA 2A specifically states students count forward by ones and tens from 0 to 100 and backwards from 20 to 0. While IOA 2B has students count forward to 100 beginning from any given number within 100 and count backwards from any given number within 20. In Unit 1, our focus was on counting forward from 0 to 10 and backwards from 10 to 0. In Unit 2, we will build on this work and extend our count forward sequence to 50. We will continue to master counting backwards from 10. There are no specific lessons designated to this AKS in Unit 2. Instead, our work with AKS 2 will occur during activating strategies as we practice our rote counting through our counting routines. Unit 2 focuses on two-dimensional shapes. Three-dimensional shapes will be addressed later in the year in Unit 4. With AKS 8, students identify, describe, and compare basic shapes encountered in the environment. They also form two-dimensional shapes and three-dimensional figures. For Unit 2, we will focus only on two-dimensional shapes. Our indicators of achievement help us better understand how students show mastery of AKS 8. IOA 8A states students should be able to identify basic shapes, including squares, circles, triangles, rectangles, hexagons, and octagons. Students identify and describe the shapes based on the number of sides, vertices, and other attributes. It is important to use shapes in different orientations and sizes, along with non-examples of the shape, so students learn to focus in on those defining attributes of each shape. Students also sort, classify, analyze, and compare two-dimensional shapes. With Indicator 8B, kindergarten students should be able to explain the location of an object in relation to another object using positional language, such as above, below, beside, in front of, behind, or next to. Indicator 8C states students use basic shapes to represent specific shapes found in the environment. Students do this by creating models and drawing shapes. The last indicator for AKS 8 is IOA 8D, in which students use 2 or more basic shapes to compose larger shapes. Students form or compose larger shapes by putting together smaller shapes through exploration and play. Students then progress to looking at images of larger shapes in which they decompose the larger shape into 2 or more smaller shapes. For students to show mastery of AKS 6, they should explain, extend, and create repeating patterns with the repetition not exceeding 4, and they should also be able to describe patterns involving the passage of time. While AKS 6 is ongoing throughout the year, specific instructional time will be dedicated to IOA 6A in Unit 2. IOA 6A states students show mastery of AKS by being able to create, extend, and describe repeating patterns with numbers and shapes, and explain the rationale for the pattern. In this unit, Students will work concretely to describe and extend repeating patterns with actions or movement, as well as shape patterns. In later units, students will create patterns, work with number patterns, and move to representational work with patterns. AKS 7 consists of physical and measurable attributes of objects and analyzing graphical displays. In Unit 2, we will focus on IOA 7B, classify and sort up to 10 objects into categories by an attribute, count the number of objects in each category, and sort the categories by count. Specifically in Unit 2, we will classify and sort 2D shapes into categories and count the number of shapes in each category. In a future unit, we will include the portion of the IOA which states sort the categories by count.
The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's take a look at our pacing guide for Unit 2. In the box which names the unit, you will see the suggested pacing. For Unit 2, we suggest about 4 weeks. The big ideas for the unit are included, as well as any links we feel could be beneficial for the entire unit. We have provided a checklist for AKS 2. AKS 2 is an ongoing standard intended for students to show mastery by the end of the year. IOAs 2.A and 2.B have been broken into specific learning targets, providing a progression and scaffold for learning. The introduction of these learning targets has been paced to help ensure mastery by the end of the school year. Students will continue to practice all learning targets throughout the remainder of the year for mastery of the overall AKS. This checklist is intended to support the teacher in collecting formative data on individual students. The checklist accounts for performance-based observations and should be used to form teacher-led and student-led small groups. This allows the teacher to provide personalized instruction based on the student's strengths and misconceptions. Next, you will see a list of AKS and IOAs which have been strategically clustered together. This is followed by our suggested pacing. Specifically, the left column provides the learning progressions for the AKS and IOAs, whether this be the concrete, representational, or abstract progression, or a progression between specific learning targets within the IOAs. Suggested manipulatives are also included in this column. The right column provides resources to guide instruction. We will begin Unit 2 with about 2 days on IOA 8.B in order to introduce positional words with familiar objects in the environment. Next, we will begin our work with AKS 8, in which we identify, describe, and compare basic two-dimensional shapes encountered in the environment. The suggested pacing for our work with AKS 8 in this unit is about 12 days. During this time, we will spend approximately 6 days at the concrete level in which we will introduce a shape a day and create an anchor chart to support students as they identify and describe the attributes of two-dimensional shapes, including the number of sides and vertices for each shape. We will classify shapes in different sizes and orientations, as well as sort shapes into examples and non-examples of identified shapes. During this time, we will also create models using basic shapes to represent specific shapes found in the environment. After our concrete work with shapes, IOAs 8.A and 8.C, we will transition to the representational level in which we will continue to identify, classify, and sort pictorial representations of 2D shapes in different sizes and orientations, as well as draw basic shapes to represent shapes found in the environment. We will finish our work with AKS 8, focusing on IOA 8.D, in which students will use 2 or more basic shapes to compose larger shapes. As a reminder, all of our work with AKS 8 and Unit 2 will focus on 2-dimensional shapes only. We will revisit AKS in Unit 4 with an emphasis on 3-dimensional shapes. After our work with AKS 8, we will move into IOA 6.A with a suggested pacing of about 3 days. We will use what we learned about shapes to now describe and extend repeating patterns with shapes and body movements or actions. These 3 days will be at the concrete level, as this is an ongoing IOA, and we will move to representational later in the year. We will wrap up Unit 2 with IOA 7.B with a suggested pacing of about 2 days, where students will classify concrete objects, specifically 2D shapes, into categories by an attribute and count the number of objects in each category. But the category count should not exceed 10. This means there may be a total of more than 10 objects, but after the 10 objects are sorted, there will be 10 or less in each category, allowing students to count the number of objects in each category and represent the amount with a written numeral. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards for guidance on additional instructional strategies for each IOA. Now, let's take a look at possible instructional strategies in action. Let's take a look at IOA 8.A, where students will identify, sort, classify, analyze, and compare 2-dimensional shapes in different size and orientations, using informal language to describe their similarities, differences, and attributes. I do notice that in this IOA, it does mention 3-dimensional figures. However, we will be learning about 3-dimensional figures later on in Unit 4. In Unit 2, we will just focus on 2-dimensional shapes. I see that those shapes are squares, circles, triangles, rectangles, hexagons, and octagons. And then I need to be able to have students know their similarities and differences, and also the attributes, which include the number of sides, vertices, and having sides of equal length. So let's take a look at a shape. When I'm teaching students for this, the pacing guide does suggest that you spend the majority of time at the concrete level. So I do want to have those manipulatives in hand, such as attribute blocks, geosticks, tangrams, geoboards. This will help students be able to touch and feel and point to those sides and vertices as they're learning the names of the shapes. As I'm teaching students each shape, I want to add on to an anchor chart. So as we're learning about this shape and learning that it's called a triangle, I want to create an anchor chart that has the name of the shape, a picture of the shape, as well as the number of sides and the number of vertices. So I'm going to have students run their finger across the sides and learn that these are sides, and then count them: 1, 2, 3. I'm going to teach students that the points or the corners where 2 sides meet is called a vertex. And this triangle has 1, 2, 3 vertices. So anytime I see a shape that has 3 sides and 3 vertices, it's called a triangle. So that comes with the identification piece as we're teaching those flat shapes. Now, I also want students to be able to sort shapes. And I'm going to have them sort them into examples and non-examples. So I have some attribute blocks here that I would give students. And all I want them to be able to do is to sort these shapes into examples of triangles and non-examples of triangles. So what I'm looking for students to understand is that anytime I see a shape that has 3 sides, 1, 2, 3, and 3 vertices, it's called a triangle. So students would sort those triangles together and know that those are examples of triangles. And because these shapes do not have 3 sides or 3 vertices, these would be considered non-examples. So I've sorted into examples of triangles and non-examples of triangles. For this IOA, I also want students to be able to classify shapes. So if given a shape, now that we've learned about our different shapes and we know their attributes, if given a shape, can students classify this shape and be able to name that shape based on attributes? So we've learned that a circle does not have any sides or any vertices. So it has 0 sides, 0 vertices. So I know that I can classify this shape as a circle because it has 0 sides and 0 vertices. I may also want students to be able to build shapes on a geoboard. So maybe I would have them build an example of a triangle and be able to justify why this is a triangle. So I'm looking for students to be able to tell me, I know this is a triangle because it has 3 sides and 3 vertices. Students may also build a non-example of a triangle and be able to justify why this is a non-example of a triangle and talk through that this shape does not have 3 sides or 3 vertices, so it cannot be a triangle. It's also really important that we show students different shapes, sizes, and orientations of triangles, squares, rectangles, hexagons, octagons, circles, all of the shapes, so that students do not create misconceptions that triangles or any of our shapes that we're learning have to look one way. So when we look at these shapes, I want students to be able to justify their thinking and know that they're triangles because they have 3 sides and 3 vertices. You may have students look at this triangle and think that it's not a triangle. They may say it's upside down or it doesn't look like a triangle. Most students are going to think of this as their traditional triangle that they've seen in lots of different places. But students need to be able to know that this is also a triangle. So you could turn the triangle this way and show students, well, do you think it's a triangle now? Maybe now they think it's a triangle because the flat side down here doesn't come and the vertex is up at the top. But if I turn it upside down, as students might say, they may now think it's not. So I'm going to have students touch and count the sides and touch and count the vertices. Also, using the geosticks is really going to help with this part of the IOA where we want students to recognize whether shapes have equal side lengths. The geosticks are color-coded based on the size of their lengths. So if I'm looking at this orange triangle, all 3 geosticks are orange. So I know that all 3 sides have the same length because they're the same color. When I look at this triangle, I can see that it has 2 blue sides and 1 green side. That's going to help students see that no, they do not have all the same side lengths. Only 2 of the side lengths are the same and 1 is different. When I'm looking at this triangle, I see that it has 3 different colors. So I know that all 3 sides are a different length. So it does not have equal side lengths. I also want students to be able to compare shapes. So I may ask students, how are rectangles and squares alike? How are they different? And I might give them 4 different shapes to look at and have them talk through how these shapes are alike and how they are different. What I'm wanting students to notice is that all of these shapes, regardless of whether they are squares or rectangles, have 4 sides and 4 vertices. Now, some students may look at this yellow square and think that it's not a square because of the way that I have the square oriented. So it's important for students to see, and you may want to turn it and ask students, is this a square now? and then turn it again and see if they think it's still a square. All I've done is rotate it. I have not changed the size. I've not stretched it out. I've not added sides or vertices to it. So yes, this is still a square. So we want students to know, okay, well, look, it has all 4 sides the same length and it has 4 vertices. So this is a square. And we want students to notice that with rectangles, the sides that are across from each other are the same length, and these sides across from each other are the same length, but that they also have 4 sides and 4 vertices, just like a square.
IOA 8C states students will use basic shapes to represent specific shapes found in the environment by creating models and drawings. So we're going to talk about this AKS first, starting at the concrete level. And there is one thing that I do want to point out. We've had our students draw shapes in the past as well as build models of shapes, but the specific part of this IOA, which is a little different, is we are now using these basic shapes to represent specific shapes found in the environment. So we want them looking at real world objects and then relating what is that shape? What is this real world object an example of? And so in this problem, Tess brought snack mix to school. Build the shapes you see in the snack mix. Well, I might want to start my students off by picking a specific piece of the snack mix. So I'm going to start with the cracker. When we look at the cracker, what do you notice about it? What shape is the cracker? And one way to do this at the concrete level is to have the attribute blocks out and have your students pick which one matches. Well, I noticed that this one is the same shape as the cracker. And I know it's the same shape because I see 1, 2, 3 sides on my shape. 1, 2, 3 sides on my cracker. I see 3 vertices on my cracker, and I also see 3 vertices on my attribute block. So this cracker is in the shape of a triangle. We can use attribute blocks and have students match shapes with represent specific shapes found in the environment. Another way we might want to do this is to use a geoboard. And I'm going to stick with my cracker here. Can you build a shape that is the same shape as the cracker? So I'm going to want my students then to build a triangle. And so we can go ahead, build that triangle, whether they use one rubber band or they use 3 different ones to represent the 3 different sides. Either of those ways would work. And how do you know that this is the same shape as the triangle? And go back over that justification with those attributes as well. Students might also build at the concrete level using the geosticks. So can you use your geosticks? So I've got a package of geosticks. Can you use your geosticks to build a shape that is the same as the cracker? So we're going to be wanting our students to use these to create a triangle. And again, of course, honing in on those attributes. Well, why is this cracker in the shape of a triangle? How did you know? Going back to those sides and those vertices. You might also want to go, well, wait a second, now is it still the same? Again, getting at that different sizes as well as different orientation. So this one is just a larger triangle, this one is a smaller triangle, but they're still the same shape because both of them have 3 sides and 3 vertices. At the representational level for this problem, you would have students then just, if you want to hone in on the cracker, just draw me an example of a triangle. Kind of going back again to those same attributes. How did you know it was a triangle? Based off of those sides and those vertices. On the pacing guide, you will also find an example of a task-based lesson called Flat Shapes in Our Community. In this task-based lesson, students will be working with indicator 8C as they use basic shapes to represent specific shapes found in the environment, and it is written at the representational level. So in this lesson, you'll kick it off by reading the book Round as a Tortilla. It is it is linked in here. If you don't have a copy, that's okay. You could watch it. But in this, they're going to use pictures. Actually, let me go back right up here. and they're going to find of your community. So you're going to look at images around your community. This one is geared towards Benefield Elementary and its community. But just like with the Chex Mix, where the students were identifying the shapes that they saw in those real world examples, students will be able to draw on these images. So they might say, oh, look here, I see that this window is made up of 4 squares, and they could outline those 4 squares. So we do have task-based lessons for this indicator as well. IOA 8D states our students use 2 or more basic shapes to compose larger shapes. When we think about IOA 8D, we can think about 2 different learning targets with this, or really 2 different types of larger shapes in which we're going to be working with. We work with larger figures. For example, what we're going to look at with this problem, where I'm going to take the shapes and build a rocket, that's a figure, and then also composing shapes. So how can we take these smaller shapes and make a new shape and describe its attributes? So here's an example of a problem at the concrete level in which we're going to compose a larger figure from smaller basic shapes. So our school is Stripling Elementary, and we are the Red Rockets. How can we use individual pattern blocks to compose a larger figure of a rocket? So with this, we might talk a little bit about how it has the body, and it's kind of a little bit straight sides here. So I'm going to use my squares to build the body of my rocket to kind of give it those straight sides. And then I noticed that it has the point at the top of the rocket, and I'm going to use one of the vertex of the triangle to give me that point. And then I want to put that at the bottom, kind of have it go out. So right here is an example of a rocket. My rocket is a larger figure, and it is composed of 3 squares, 1 triangle, and a trapezoid. I know these are squares because each one has 4 sides. The 4 sides are equal, and it has vertices. I know this is a triangle because it has 3 sides and 3 vertices. And when I put these 5 smaller shapes together, I'm able to make a larger figure of a rocket. This concrete exploration might be very wide and open, where you just give your students a bunch of pattern blocks and have them make shapes and make pictures of things, and then tell me, what did you make? What's it made of? You can also find outlines of larger figures in which it's showing you, hey, this is a fox. Go ahead and use your pattern blocks and fill in this template. But we can always begin with free exploration as well. As we move from composing larger figures at the concrete level, we're then going to move into composing larger shapes. So we're going to use smaller shapes to make a new shape. Tangram pieces are great with this. We want to begin with the opportunity. Let's get my pattern blocks out of the way. Let me grab a pack of tangrams. We want to begin our students at the concrete level and let them have free exploration. What can you make? Can you use these shapes and make new shapes? So I don't know. I'm just going to stick some things together and see what I can make out of it. Let's see. Ooh, I just took 2 triangles and a square. Triangles have 3 sides, a square has 4 sides. When I put these shapes together, I've made a new shape. I made a rectangle, and a rectangle is a 4-sided shape. It has 2 sets of equal sides, and then it has 4 vertices. So I'm using smaller shapes to make a new shape versus making a figure. This is very open-ended exploration. Just see what you can do, what shapes you can make. You can be more specific and ask to compose a specific shape. So I might tell my students, can you use your tangram pieces and try to make a square? And so they're going to be, twisting and turning and seeing what they can do to make that square. And then hopefully they're going to end up having success. I used 2 triangles to make a square. I know it's a square because it has 4 sides. All 4 sides are the same length, and it has 4 vertices. So that was just being specific, naming the shape that I wanted them to try to compose. You can also be even more specific and ask them to build a specific shape with a specific number of pieces. So for example, in this instance, I could say, can you build me a square using 2 smaller shapes? So with that, you're telling them exactly how many pieces to use as well as what shape to make. I could use these 2 triangles to make a square. I could also use the 2 smaller triangles. Your students are going to have to do lots of manipulation as they're trying to figure out how to turn their shapes to make those new shapes. So that is some of the work at the concrete level. When it comes to IOA 8D, using 2 or more basic shapes to compose larger shapes, which we kind of break down into larger figures, as well as actually making a new shape and describing those attributes. At the representational level, grab my sheet, students are typically given pictorial images of figures or shapes, and they're asked to decompose it into smaller shapes that were used to make it. So it could be a figure. I could show them the outline of a rocket and then say, hey, can you show me what little shapes would be used to make that rocket? Or it can be an actual shape. So in this example, Brady used smaller shapes to make this larger shape. What smaller shapes did Brady put together? So typically, our students are going to have needed multiple opportunities to explore and play with the shapes at the concrete level before they're moving to the representational level, because this is a whole different level of geometric thinking that is needed. And if our students haven't explored and got to touch the manipulatives to make new shapes at the concrete level, this is going to be very difficult for them. But hopefully, if they have and they've taken, pattern blocks and they've noticed, ooh, I can take 2 squares and put them together, and now I have a rectangle, then seeing this rectangle hopefully was going to be easy for them to then realize, oh, I could just go ahead and decompose it into smaller shapes. Maybe they decompose it into multiple smaller rectangles. For example, I could go this way and now I have 2 rectangles. I could go this way and draw 2 and have 3. Or I might be able to see, ooh, if I draw the diagonal, I now have 2 triangles that are each 3 sides, and they've been used to make this rectangle. So we want our students to have multiple opportunities at the concrete level to compose larger shapes using 2 or more basic shapes, so that then they can do the work at the representational level. IOA 6.8 states students will create, extend, and describe repeating patterns with numbers and shapes and explain the rationale for the pattern. In this unit, we will describe and extend patterns at the concrete level. We do this with body movement and 2D shapes. And please remember, this is an ongoing IOA. So later in the year, we will work on creating patterns as well as look at repeating patterns with numbers or with letters. There are a couple vocabulary words that we use when we're talking about patterns that I want to talk about for just a moment. Core. The core is the string of the elements which repeat. So you will see, we're going to talk a lot about the core, and our students are going to be able to identify the core. Well, it's going to help them to describe the pattern and explain the rationale. The other vocabulary words that you might notice when you read in on our patterns is either repetition or iteration. The repetition or iteration is how many times the core repeats. The repetition of the pattern in kindergarten should not exceed 4 times. So as you look at my pattern I have right here, so far my iteration, I have it repeating 3 times. So here's my core. There's 1, there's 2, there's 3. This pattern should not exceed but 1 more time for the work that we're doing in kindergarten. Of course, if our students are creating their own patterns and they repeat it more than 4 times, that is absolutely okay. But when we're giving them patterns to work with, we don't want it to repeat more than 4 times. Another nuance with this is we also don't want to stop in the middle of a iteration or in the middle of a core, so to speak. So here is my core, triangle, triangle, square, and it's repeated 1 time, 2 times. I'm not going to show this because that entire core has not been repeated. We should always have the core completely repeated when we give students patterns for them to describe or extend. So we want that whole core to repeat no more than 4 times. So let's look at this problem at the concrete level. We're going to start by talking about how we would describe it and then what that would look like with extending. So Olivia created the pattern. Describe her pattern. So if this is a problem that I was going to do with my students or model for them, let's kind of think through what we would want to think through for our students. A lot of times we might start by just saying, what do we see? That helps give the pattern some rhythm. And for some students, that's going to help them to notice what part is repeating over and over, as well as, of course, the visual. But I have triangle, triangle, square, triangle, triangle, square, triangle, triangle, square. And so what I'm noticing is if I look at this, I'm seeing that I do 2 triangles and a square, 2 triangles and a square, 2 triangles and a square. So it looks like this is the piece of the pattern that keeps repeating. 2 triangles and then a square. 2 triangles and then a square. I'm just going to separate it out. 2 triangles and a square. By physically breaking this apart, that might help your students to see this is my core. This is what's going to continue to repeat. Our students don't have to know the vocabulary words repetition or iteration, but we do want them to know the core. They might break it apart to help identify the core, or some students may want to draw. Here's my core. I have triangle, triangle, square, and it's going to repeat triangle, triangle, square, triangle, triangle, square. So if I want to describe this pattern has a core, or it repeats 2 triangles and a square, and then 2 triangles and a square. Or I could say triangle, triangle, square. It's a triangle, triangle, square pattern. And in order for our students to extend the pattern, maybe the problem said Olivia created this pattern, extend her pattern. Our students, of course, would have to go through that thought process of identifying, well, what is the core? What is the piece that repeats, so that they then know what to do to extend. So, of course, we've got this. We've identified our core. We know what keeps repeating is the triangle, triangle, square. Triangle, triangle, square. So here it's repeated again. Triangle, triangle, square. So what do I need to do next to extend this pattern? I need to go ahead and think about my core, that triangle, and then a square. Triangle, triangle, square, triangle, triangle, square, triangle, triangle, square, triangle, triangle, square. So I've extended this pattern by identifying what is the core, what is the part of the pattern that repeats, and then I repeated it at the end to be able to extend. Again, in this unit, we will only be working at the concrete level with describing patterns by identifying that core and then extending the pattern. Specifically just with body movement and shapes. We'll move on into other parts of this IOA later in the year.
Let's take a look at IOA 7.B, where students will classify and sort up to 10 objects into categories by an attribute. They will then count the number of objects in each category and also sort the categories by count. For Unit 2, we will focus on sorting objects into categories by an attribute and then counting the number of objects. The last part of the IOA, where students will sort the categories by count, will come in a later unit throughout the year. For this IOA, we want students to be able to sort by an attribute, but we don't want the category count to be greater than 10 once sorted. So as you can see for the problem that I'm about to show you, I do have more than 10 objects, and that's okay. You may have more than 10 objects as students are sorting, but once students have sorted the objects, we want the category to be 10 objects or less. All right, so we have the situation. Maria has a group of shapes and wants to organize them into categories. How can Maria sort her shapes into categories by an attribute? Well, we just finished learning about AKS 8, where we identified and classified and compared two-dimensional shapes. So using shapes for this IOA is a great way to incorporate all of that they just learned. Now, you may have students who do not sort by a shape attribute. So students initially may look at these objects and see visually that there are 3 different colors. So students may first sort by color. As students are sorting by color, they should have 3 categories: a group of yellow shapes, a group of blue shapes, and a group of red shapes. And that is definitely okay. Students have sorted the objects by an attribute. The attribute is color. And now we want students to count the number of objects in each category. And we want them to be able to label those categories. So I can see in the yellow category, we have 1, 2, 3, 4 yellow objects or 4 yellow shapes. For blue, I have 1, 2, 3, 4, 5. There are 5 blue shapes. And for the red, I have 1, 2, 3, 4, 5, 6. 6 red shapes. And this would be what we're going to do in Unit 2. We're going to have them look at a set of objects, decide on an attribute to sort them into categories by that attribute. For this example, we use color as the attribute, and then count and label those categories with the number in each. Now, like I said earlier, the piece about the sorting the categories by count, we will do later on in the year. Mine happens to already be that way, but it may have been where this group of 4 was on the right side and it was not in order. And later on in the year, we'll have them sorted into number order. Okay, so that's one way that students might sort these shapes. Students might also see that the shapes are different sizes, and size is an attribute that we can sort these objects. So they may see that there are big shapes and small shapes and sort into 2 categories, big and small. So as I'm sorting these shapes into big shapes and small shapes, I see that I now have 2 categories. And the attribute that I sorted by was size. Again, we want students to be able to label those categories with the number in this category. So in my big category, I have 1, 2, 3, 4, 5, 6, 7, 8. And in my small attribute category, I have 1, 2, 3, 4, 5, 6, 7. So again, students chose an attribute, sorted into categories, and then labeled those categories by count. Now, because we have just finished AKS 8 learning about shapes, students hopefully will see that they can use the attribute of sides or vertices. So students may begin to sort by shapes that are called the same thing. So I see that I have a category of circles. These shapes have 0 sides and 0 vertices. I see that I have shapes with 6 sides and 6 vertices. There are shapes with 3 sides and 3 vertices. And then there are shapes with 4 sides and 4 vertices. Okay, so for this attribute, I end up having 4 categories that are sorted by sides and vertices. And once again, I would label 1, 2, 3, 4, 5. This group has 5 shapes or 5 objects. 1, 2, 3. This group has 3. 1, 2, 3. 1, 2, 3, 4. So again, the student has chose the attribute of sorting by sides and vertices, and then labeled those categories by the count. In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. From the Georgia DOE's Comprehensive Grade Level Overview.